I'm Ophir, and together with our team at Princeton, we're launching SWE-agent today, which we're super excited about. SWE-agent is an autonomous agent that using GPT-4 can take a GitHub issue and automatically turn it into a pull request. We're the first to evaluate on the full SWE bench test set, and we get great results. It's a fully open source project, and we've gotten lots of insights from the past half year of working on agents on how to build really, really powerful software engineering agents. So in this video, I'm going to take a deep dive into a sample trajectory of SWE-agent fixing a real bug from the sklearn GitHub repository. And we're going to see how it did that, and then I'm going to give you lots of insights into how it works and things we learned when we built this agent. Okay, so let's get right into it. So this is our trajectory view. So once we're done fixing a bug, we can kind of take a look at what the agent did to fix it. And so we're going to start with the issue text. And so this is taken right off of GitHub from the sklearn repo. And this issue is titled, with MLP classifier, when warp start is true or coefs are provided, fit doesn't respect max iter's. And this user found a bug, and they were really nice, and they gave a description of this bug, and they provided some code. So they're training an MLP on some random inputs and outputs, I think for 3 iterations. And they expect a warning to sound after every iteration, but in reality, it only happens once. And so yeah, that's the bug. And so we give that to our agent. And I'll show you later why the agent decided to do this. I mean, it's because we instructed it to do this. But the agent decides at first here to create a file called reproducebug.py, which will contain this code here for reproducing the bug. And so the agent issues a command, create reproducebug.py, after issuing this thought describing what it's about to do. So after it issues this command, the environment automatically creates a file called reproducebug.py, and it's empty, and it shows the agent, hey, this is the file, it's in the repo, it's called reproducebug.py, it's got just one line and it's empty. And then we always, at every turn, we give it some useful information, so we always tell it where the open file is and what current directory we're in, and then we tell it, okay, what's the next thing you'd like to do? And so the agent says, I want to paste in the example code from the issue to reproduce the bug. And so we have this edit command. And to use the edit command, we've told the agent that it needs to tell us what's the first line that it wants to edit, like what's the range, like where do you want to start and where do you want to end. So right now there's just one file, so it starts at 1, it ends at 1, and then what is the content of your edit, so that's going to come here, and then at the end we want it to say end of edit. And as you'll notice, whenever it's issuing commands, it's only allowed to issue one command at every turn, and it surrounds them in this syntax, just like code is usually formatted in GPT. And so it issues that edit command, and so the environment then tells it, okay, here's what the file looks like now. As you can see, we've inserted all the text. So the agent is like, great, now let's run the script. It runs the script, and this is training an MLP. This is really cool that an agent can do this. And as you can see, it only issues that warning once that the user talked about. And so the agent correctly says that the output confirms the issue. And the agent has decided that the next thing that it should do is find the multi-layer perceptron file. And we tell it that we have not found any file with its name. And then it's like, oh, actually, it might start with an Let's go and we search for that. And we find one match. And then it opens it. And then we've built a file viewer for the agent. So when we first started developing SWE-agent, we would give the agent the entire file every time it wanted to view a file. But if you've worked with agents, you'll know that lots of context really confuses them. Even if you're using the strongest models around, like GPT-4 Turbo, that have a really long input sequence length, it's still really hard for them to read long inputs. And so what we decided to do is build this file viewer, which can only display up to 100 lines at a time. And then it always tells you how many more lines are below what it can display to you. And so when the agent asks to see this file, we show it the first 100 lines. And then it decides to search that file for the function fit. And we tell it that we found one match on line 728, and this is how it looks. And the agent's like, great, let's go to that line. It goes to that line. And then it's like, this function actually delegates the fitting process to _fit. So let's find that. So it searches for that. We find one match, 422. The agent goes to that. And then decides it wants to find where an iter is defined. And we find 29 matches. And we show the agent all of these different matches. And then it decides to go to the match found on line 683. So we focus our editor to line 683. So it means we show the agent 50 lines before 683 up until 60 lines after 683. And then it's like, okay, I want to scroll up actually to see something a bit above this window. So we scroll up the window. And then it wants to scroll up a bit more and a bit more. And finally, it's like, okay, I found the code that's causing the bug. It's on line 433, and I'd like to edit it. So let's look at 433 first pass, and there's the rest of the stuff. And what it wants to do here is it wants to redefine first pass and then add this if right after it. Now, we've been working on SWE-agent for the past 6 months, and basically the largest problem that these agents have is that they're really, really, really bad at editing files. They don't do the syntax formatting, the white space formatting correctly. They make mistakes with regards to which lines need to be edited. They're just really, really bad at editing files. And what we're going to see here is a pretty classic mistake that the agent makes all the time. It wants to edit line 433 to 435, but it accidentally says it wants to edit line 433 to 433. What it's saying here is that it wants to change this line to these 3 lines, but that's incorrect, because if you change this line 433, you'd also want to delete these 2 lines, right? If you're redefining first pass, you'd want to delete these 2 lines. And so the way we fixed this incredibly large hurdle with editing is that we add a linter into the editing process that tries to make the edit and then uses a linter to verify whether that edit has any syntax issues. And if it does, we don't let the agent make that edit. And that's what happens here. It says your proposed edit has introduced new syntax errors. Please understand and retry your edit command. And we give it the linting output. And then this is another classic agent thing where it just basically issues the exact same command again. And then we tell it again, nope, there's a syntax error here. And finally, I think this is where it's going to get it right. Yep. Here, it decides to edit 433 to 435, which is the correct edit. And then we actually execute the edit, and we show the model that the lines have been edited. There it is. And now the agent is like, okay, I've just edited my code. let's see if the bug is still there. And so it runs Python reproduced bug.py, and this time it's being issued these 3 warnings, which is exactly what the user wanted. And so the agent is like, great, we fixed the bug. We can remove reproduce bug.py, and then it knows that it's done with this task, and it issues the submit command, which shuts down the session and sends off this patch for evaluation. And because SWE-agent is tested using SWE-bench, we have automatic evaluation for our patches, and SWE-bench here indeed tells us that the patch was generated as we saw, it was successfully applied to the repo, and that it successfully resolves the issue at hand. We have unit tests in SWE-bench that verify that the bug that we're evaluating on has been fixed. So that's it. I know it looks really, really simple, but this took us a lot of time to build because there are a lot of small things that kind of keep on tripping the agent up, and we had to spend a huge amount of time, and we had to run a lot of experiments to figure out exactly what types of things the agent could fail on and how to help the agent not make those types of mistakes. And so now I'm kind of going to show you the behind the scenes of how the agent works, and I'm going to talk about the things that kind of really helped us take this from a baseline agent, which couldn't really do much, into the SWE-agent model, which is able to solve 12% of the issues in SWE-bench. So if we scroll all the way up here, I didn't show you this before. Now I'll show this to you. Our first message to the language model is not just the issue. We actually have 2 messages that precede that. 2 messages that precede the issue text, and here they are. The first one describes the tools that we've built for the agent. So I showed you the edit command, the create file command, the open command. So these are all commands that we had to build to enable the agent to do all this amazing work. If you don't provide it with special build commands, it's not going to do very well. And so in our first message, we tell the agent, you're an autonomous programmer, you're working directly in the command line with a special interface. And then we have the list of commands, open, go to, scroll down, scroll up, and an explanation of what they do. And I think we've seen most of these commands. We have search dir, search file, edit. And then the next thing we explain is the response format. And again, this is something that may look simple, but it involved a lot of experimentation to figure out exactly what the best response format was. But what we settled on when we saw that worked best was this response format, kind of React style, where you always ask for a thought first. We ask the agent to first discuss what it wants to do and then issue a single command. And so we give it an example of that here, where we're like, hey, you always have to have a discussion first and then a command, and then we give it an example where we're executing one turn of the agent, where we're asking it to show the files in a directory. And then I kind of wrote this prompt and I tried to repeat all the important things. So I tell the second time, please only issue a single command. If you want to do 2 things, please do one thing first and then do the other one later. And then we ask the agent not to use any interactive commands like vim. So that's kind of the interface definition, where we're telling the agent kind of what environment it's in. And then we found it to be extremely important to also provide the agent with a demonstration trajectory. So when we're fixing a new issue, we always first give it this demonstration where we manually fixed a previous issue, and we put in that entire trajectory as an example so the agent kind of knows how to behave in this new environment. And so the demonstration bug is a totally different bug. It's a bug in, I think, this library called Marshmallow. And so we have the issue text here, and this user says, hey, I just found quite strange behavior of time delta field serialization. And the user has some code here which causes this bug. And they tell us that this bug prints out, this code prints out the number 344, but it should print out 345. And so in this demonstration, we kind of show the agent how we would solve that bug using this interface, right? So we create reproduce.py, and then we add all the code to reproduce the bug into reproduce.py. Then we execute it, and we get the buggy output, and then we cd into the right directory, and we find the file that causes a bug, and we open it to the right line, and we edit that line, and we fix a bug. And I guess we kind of fail here. We issue an incorrect fix with this indentation error to show the model that it should listen to the linter. Then we issue the correct edit, and then the bug is fixed. And so we type rm reproduce.py, and we submit this session so it can be evaluated. And so yeah, so every SWE-agent session starts with 2 automatic system messages, where the first one is kind of a description of the environment, and the second one is a full demonstration on how to solve a bug in this environment. And so when we give our agent this test time neural network MOP classifier issue that it's never seen before, it kind of has a pretty good feel for how to act within this interactive environment and what types of things it should kind of try to do. So it knows that, okay, maybe the first thing I should do is create this reproduce.bug.py, copy the code into it, try to run it, see what happens. But from that point, it's on its own. It needs to try to solve a bug. It sometimes needs to be very creative, do all kinds of crazy things to try and solve a bug. And yeah, when it's done, it just presses, it just submits the submit command to let us know that it has finished. So yeah, agent design is super, super hard, because we think that these large language models like GPT-4 were trained not really for interactive tasks, but more for like kind of one-off questions where you just ask a question and get an answer. And so we did notice that even the best model in the world, GPT-4 Turbo, had a really hard time acting as an agent. And so in the paper that we'll release soon, we're going to talk about what we call agent-computer interface, which is this kind of interface that we made for the language model to have as simple of a time as possible acting as an agent. And so it involves this kind of output format that we ask the agent to talk in. It involves the input format of how we feed in the environment state at every turn. And it also involves all these commands that we had to create to be very, very LLM friendly. We're building all these programs, this file editor or searching command. We're building all these programs not for human engineers, we're building them for language model agent engineers. So that's something totally new, and you have to run a lot of experiments to kind of see what works, what doesn't work. And sometimes very, very small, tiny things can lead to huge differences. I'll show you just one thing. At a certain point in time, we found that it was really hard for the agent to kind of navigate within the directory structure. It would always forget where it was and kind of try to issue the same command twice. And so something that really increased our accuracy on the dev set was including this open file kind of reminder. Every time the environment returns output to the agent, it always tells it what file is currently open, and what directory is currently open. That's what I meant to talk about, the current directory thing, not the open file. So telling the agent the current directory really, really helped it understand, okay, this is where I am, and we gave it the full directory, and then it didn't have that issue anymore with navigating to a specific directory that I wanted to get to. So yeah, This is going to be it. This was just one example, but we're going to post all of these examples of trajectories where it correctly fixes these bugs, which are sometimes very, very complex. We're super proud of this. It's all open source. You can go use it and play with it right now. And of course, we're just getting 12% on SWE-agent, which was obviously a lot of hard work, but there's a lot more work to be done here in understanding how to make these agents even better at fixing complex software issues. So we're super excited to see what the community does with this. Thank you so much for watching.